Hello, welcome to another tutorial. So it reads, a new lined canal shall be constructed in an African river basin. The maximum design rate of flow is 100 cubic meter per second. The side slope is 2:1. And longitudinal bed slope is 10 centimeter per kilometer. The channel is lined with concrete, for which the design Manning roughness coefficient is 0.0182. The cost of excavation of the channel is $8 per cubic meter, and the total cost of lining is $100 per square meter. Determine the cost of constructing 1 kilometer of the channel in millions pounds, considering the following two cases. Case 1, the bed width is 4 times the water depth, which means B is equivalent to 4y. And case 2, the channel section is base hydraulic section. Then we finish by saying, which section will you recommend and why? So first of all, let's take the given values. From the question, we find that Q is given as 100 cubic meter per second. And then we have a component M. A component M is the first value, like the slope, side slope is 2:1. So the value of M will be equivalent to 2 in case of the trapezoidal cross-sectional. Then another thing, longitudinal bed slope, this we said from the previous is our S, or sometimes we can call it S naught, which is given by 10 centimeter per kilometer. But we said 10 centimeter per kilometer is like you take 10 centimeter, you divide by 1 kilometer, which is 100 centimeter. That is why we have 10 times 10 power negative 5. Then Manning's coefficient, we have been given as 0.0182. and excavation cost $8, all that. Now, case number 1, we consider that the bed width is 4 times the water depth. Like the value of B here, you see, we write in the first case that B is equivalent to 4y. Now, remember, how do we interpret the side slope? Side slope, when we have 2:1, remember, the first value 2 is horizontal value, then the second value, the vertical value. Take it very keen, because we are saying the side slope 2:1. So 2 is horizontal, 1 is vertical. Another thing I want you to differentiate, remember, bed slope is what we call S. Bed slope is S, but for side slope, we use M, whereby M will be equivalent to the first digit when the second digit is 1. So from there, now we shall say Q is equivalent to 1 over N, area power 5/3, multiplied by bed slope power half, divided by weighted perimeter power 2/3, which means area is equivalent to now Y, which is depth, into B plus my. Now from this diagram here, area is Y into B plus my, which is equivalent to now our Y plus, now instead of B, we say we put there 4y. So Y into B, which is 4y plus my. Remember our M is 2, then we have Y, which is equivalent to 6y squared. So our area is 6y squared. Then our weighted perimeter, for the case of trapezoidal cross-section, our weighted perimeter is width B plus 2y square root of M squared plus 1, which is B is 4y plus 2y. Now our M is 2. 2 squared is 4 plus 1 is 5. That's why we have root 5. It will give us 8.47y. Now, if we substitute in this formula here, Q is equivalent to 1 over N, it will be 100, which is Q is equivalent to 1 over N is 0.0182. Then our area is 6y squared power 5 over 3 divided by our weighted perimeter is 8.47 power 2 over 3. We multiply by the bed slope, which is 10 times 10 power negative 5, all that power a half. So you will end up now, if you take the constants on your left-hand side and the variable on your right-hand side, you find like 182.149 is equivalent to 6y squared power 5 over 3 divided by 8.47y power 2 over 3. Now here we shall use what we call trial and error method. How does it work? Trial and error method, what we'll do, now we will be putting different values of y in y squared in the numerator and in the y at the denominator at the same time, until where this value here, the value on our right hand side will be equivalent to our value on the left hand side, which is 182.149. So we'll come up with such a table. So see my table here, I have y, left hand side, right hand side. Remember, left hand side is constant, it's just 182.149. So it is one value all through. But for the right hand side, wherever I take value of y, I input into y squared and into y and compute the value. For example, when y is 2, now I put 2 here, 6 times 2 squared power 5 over 3, then 8.47 times 2, which is y, 2 over 3. So when I compute, I get 30.274, which is very low than the 182.149. So I will move to value of y to try 3. When I try 3, now when I replace where there is y, I replace 3, I find 89.25, which is still very low. Our target is 182.147. Then I will move to, maybe I can try 3.92. When I replace where there is y 3.92, I find the value on the right hand side is 182.148. Since 182.148 is more or just equivalent to 182.149, I can conclude and say, hence, the suitable value by trial and error, suitable value of y is 3.92, which is approximately 4 meter. Now, after getting 4 meter, we can now say, remember we said our B is equivalent to 4y. If our y is 4, then our B will be 16 meter. And now our area was 6y squared. It will be 6y squared, which is 6 times 4 squared, which is 96 meter squared. Our weighted perimeter was 8.47y. Where there is y replaced with 4, I get 33.88 meter. Now, since Q is 100 cubic meter per second, which is greater than 85 cubic meter per second, we add a freeboard of 0.9 meter. Now, this we have another table which specify the limits. So when your discharge is more than 85 cubic meter per second, we provide a freeboard. Freeboard is where if you design a level, your level of water in the channel will be 9 meters, you add another extra depth to take care of waves or unexpected high discharge. You call it freeboard. Freeboard is like a factor of safety to ensure that if in case the discharge is slightly more than your predicted or your designed discharge, it will not overflow. So we add a freeboard of 0.9 meter. Now, now we want to compute the excavated depth. So excavated depth will be 4 meter, which we have calculated, plus a freeboard of 0.9 meter. So you get it is 4.9 meter. So during excavation, we'll excavate not 4 meter, but 4 meter plus 0.9 meter, which is 4.9 meter. Then excavated area. Now remember here, excavated area will be equivalent to, we said, it is y, excavated depth y into this is into 4y plus 2y, like that is into b plus 2y. So which is 4.9 into 16 plus 2 times 4.9, 126.42. Then excavated weighted perimeter, it will be 16 plus 2 times 4.9 root 5. Remember, we are just substituting these formulas we had before, but now what we are doing, in place of, instead of using y as 4, we now use y as 4.9, because now we shall excavate 0.9 meter more for freeboard, or to provide added security. Now, excavation cost will be equivalent to, now excavation cost, it will be the area multiplied by the area. Actually, excavation cost, technically, we mean, excavation cost, we mean, we take the volume of excavation times cost, which is volume is given by area times length. We are told 1 kilometer, so we have 126.42 here. I multiply by 1 kilometer, which is 1,000 meter, times this 8 is the cost of excavating 1 meter. So I get 1,011,360 USD. Then the cost of lining, remember now lining goes with weighted perimeter. It will be equivalent to weighted perimeter multiplied by length, which is 1,000 meter, 1 kilometer, times 100. Because they told us is the cost of lining is 100 times 100, you find it 3,657,000 USD. So the total cost in terms of USD of constructing the canal will be 4,668,360. So if you convert that money into pounds, you will find it is 3,547,954 pounds. Now, that was case 1. Now, case 2, we look at the best hydraulic section. Now, remember, for the best hydraulic section, you need to note the following. For the best hydraulic section, the value of hydraulic radius is equivalent to depth over 2. And another thing, 2 into width plus my is equivalent to b plus 2y square root of 1 plus m squared. Substituting, remember m is equivalent to 2, but making b the subject, you find like our b will be equivalent to 0.47 y. Now let's compute area. Area, we are still using the same formula. Area is equivalent to y into b plus my, where our y, our y is y, then our b is 0.47y plus m is 2y, so we find our area will be 2.47y squared. Now from the formula q is 1 over n a RH power 2 over 3 bed slope power half, you find 100 will be equivalent to 1 over 0.0182. You multiply by 2.47y squared, which is area. I multiply by hydraulic radius. We said it is a y over 2 for base hydraulic section. Y over 2 power 2 over 3 times our slope was 10 times 10 power negative 5 power half. So this will give us, this. It will give us like the value 182. When you compute with the calculator, 182.15 is equivalent to 2.47 y power 8 over 3 a half power 2 over 3. Now, if you compute that, we take constants on the left-hand side and variable on the right-hand side, you get 117.055 is equivalent to y power 8 over 3. So from here, if now you compute the value of y, if you make y power 1 or y the subject, you find like y will be equivalent to 5.965 meter, which is approximately, for convenience of construction and excavation, you take 6 meter instead of 5.9 0.965. Now we said breadth was B was 0.47y. So we replace 0.47 times 6 meter. You get B will be equivalent to 2.82 meter. And like we said earlier, since Q, the discharge is 100 cubic meter per second, which is greater than 85 cubic meter per second, you have to add a freeboard of 0.9 meter. So the excavated depth will be 6 meter, which we got added on to 0.9, which is freeboard, giving us 6.9 meter. So excavated area, now we just replace y into b plus my. So what we are changing now, instead of y, we use y excavated, because area excavated, you get 114.678 meter square. Excavated weighted perimeter, it will be the same. Instead of y, we use y excavated. It will give us 33.678 meter. Now, excavation cost, we say we look at the volume. So volume is given by area times length, so which is 114.678. I multiply by 1 kilometer, which is 1,000 meter, times cost per meter, which is 8. I get US dollar 917,424. Then lining cost, we use the excavated weighted perimeter. We multiply by length by the cost, which is USD 3,367,800. So the total cost will be US dollar 4,285,224. When you convert to pounds, it will be 3,256,771 pounds. Now, the question was, which section will you recommend? Because in construction, we look at the cost. Whichever mode give us the least cost and we achieve the same specification, the desired output, it is what we go for. So here, I will recommend the base hydraulic section, since it can be done at a lower cost, but maintaining the maximum discharge and channel safety. Thank you. Any question, drop in the comment section. I'll go through and respond to each one of you.